Hello students, yet again with another video on acid and base. I, Dr. N. Kavita, welcome you all to LPV Chemistry, Learn, Practice and Victory. Students, so far we have seen what is acid and base, indicators, neutralization reaction, what happens when acid and base reacts with metal, metal carbonates, bicarbonates, and water. How hydronium ion is formed. So, I think this is the basics of acid and bases. Now, we will move on to some questions which, for these questions, you have to think answers out of the box. So, we'll move on with the session today. Magnesium oxide is not an acid, it is a base. Let me explain you how to understand this concept. I'm going to draw a periodic table. I hope you people remember few of the elements in the periodic table. This is the S block, P block, D block, and this is the inert one, inert elements. 8. 1 and 2 are alkali and alkaline earth metal. We are interested in the sixth group, which is your oxygen, and these group 1 and group 2, they tend to react with oxygen to form the metal oxide, and they are active metals and also called as reactive elements. Let's try to understand why it is so. The magnesium oxide, in magnesium oxide, the magnesium tries to give away its 2 electron and tries to become positive ion. Magnesium, I'm going to just draw the outermost shell, which is 2, 8, 2. So magnesium has 2 electrons in its outermost electron. Now you all know that oxygen has got 2, 6, total 8 electrons in the outermost, total 8 electrons, which is its atomic number, and it has total 6 electrons. Now what happens is, in order to become the stable electronic configuration 2, 8, the magnesium tries to, you know, it easily accepts the electron. So the electron from magnesium is transferred to oxygen. I hope you're understanding the concept. Magnesium, it loses electron and oxygen gains electron. Now oxygen forms the octet after gaining 2 electrons. It becomes 8. So students, you have to remember the concept. Oxygen, it takes up 2 electron to become oxygen 2 minus. That is how Mg plus MgO is formed. Now, this is how MgO is formed. Now, because the transfer of electron has taken place, you have to remember that this is ionic bond, not a covalent bond. In ionic bond, the transfer of electrons takes place from metal to non-metal, whereas in covalent bond, sharing of electrons takes place. So now I hope you have understood why the magnesium oxide forms the ionic bond. Let us now take magnesium oxide, add water to it. Now this tries to become magnesium hydroxide. Oxygen 2, hydrogen 2. This magnesium hydroxide, now when dissolved in water, you can find that this magnesium in water, it forms Mg2 plus because it completely dissociates into OH minus ion. This OH minus ion is making the magnesium hydroxide a base. Base is a one which releases OH minus. Hope you remember the definition of acid. Now, if the question is changed, like sodium sodium oxide, what will be the answer? Let me tell you that as you move from S block to P block, the acidity increases. This is basic in nature, and the first group elements are more basic. I'll tell you why. Here, the the sodium metal, which has got 11 atomic number, sodium becomes Na plus by leaving one electron. This Na plus is 2, 8. Initially it was 2, 8, 1. So it has a tendency to lose electron. So it has lost its electron and it has become a cation. I hope you are very clear about this concept. There is only one electron in the outermost shell. Now, the oxygen, which oxygen forms, oxygen has got total 6 electrons in the outermost shell. For convenience, I'm just drawing the outermost shell, although it has got 6 electrons, and now it requires plus 2 electrons to become 2, 8. Now what happens is this sodium, it transfers its 1 electron, and when it transfers its electron, it 1 electron is not sufficient. So again, another sodium, it gives its electron as well. Now sodium, there are 2 sodium which gives 2 electrons. Hence Na2O is formed ionic, basic, and it's a base. So in case the question is made a little more tricky, then you have to remember that ionic bond is formed and this is a base more basic than the magnesium oxide. Okay, students, now I'll wind up with the session. I hope you would have found this session interesting. Thank you very much.